Hello, everyone. Thank you for coming today. Today, I will introduce you to the content related to charge case. Today's presentation will mainly focus on the charger case, covering aspects such as IC types, setup environment, software framework, and software development. This report will primarily provide an overview, and for detailed technical information, you can refer to the SDK online documentation. The charger case supports 3 platforms, with the corresponding EVB and target shown in the figure above. If you need to purchase an EVB, please check purchase link. The screen adapter boards for the 3 hardware platforms are divided into 2 sets. One set, left, supports RTL87X3E and RTL87X3EP, while the other set, right, supports RTL87X3D. The adapter board for RTL87X3D requires separate power supply via Type-C. After obtaining the SDK, within the SDK or tool directory, the functions of the tool files marked in the table above, from top to bottom, are as follows. 1. Serial communication tool. 2. Log printing tool. 3. Image conversion tool. 4. Parameter configuration tool. 5. File burning tool. In the SDK or tool or gadgets directory, there is also an important tool whose function is to package the user's UI resources, including fonts and images. For specific usage instructions, you can refer to the Files section of the charge case documentation. After obtaining the SDK, if you want to run the charge case demo on the EVB, you can flash the bin files from the 3 paths mentioned above. The IC type and IC model in the paths can be automatically adapted to the IC that the customer has. For detailed flashing steps and instructions, please refer to the Building and Downloading section in the charge case documentation. After completing all the flashing and performing a reset, the screen will light up and display normally as shown in the image above. Customers can test the GUI effects in the current environment or pair it with a headset for testing. For detailed steps, please refer to the Testing with Bluetooth Headset section in the charger case documentation. To regenerate the app bin, you can modify the macro settings in the app_flags.h file by enabling macros corresponding to the charge case and then recompiling. This will generate a default version of the charger case app bin. Macros corresponding to the charge case is a product macro, and it controls the toggling of other module macros within the same file. Customers can enable or disable these module macros according to their needs. The interfaces supported by the charger case are shown in the image above. The charger case supports speakers, a microphone, and buttons, as well as various data input interfaces such as line-in, USB, and SPDIF. It connects to the headset via a UART interface and can also support touchscreen displays. For more detailed information, please refer to the block diagram section in the charge case documentation. The wireless topology of the charger case is shown in the image above. The charge case can connect to a smartphone via BLE and can send data to the headset through CIS or BIS or ACL. For more detailed information, please refer to the link topology section in the charge case documentation. The audio data stream topology of the charge case is shown in the diagram above. The charge case supports 4 types of audio streams. The data stream from the input device can be transmitted to the headphones via CIS and BIS. Additionally, the charge case also supports local playback. For more detailed information, please refer to the audio stream section in the charge case documentation. The overall software architecture is shown in the image above, with different colors representing different layers. Gray indicates hardware-related components, purple represents third-party code, blue signifies features developed by Realtek, and orange denotes custom development at the app layer. For specific introductions to each module, please refer to the Software Architecture section in the charger case documentation. The overall software task framework is shown in the image above. The tasks that users might interact with are the application task and GUI task. For detailed information on each task, please refer to the Task and Priority section in the charger case documentation. The features supported by each IC are shown in the image above. For detailed information on each feature, please refer to the Supported Chipsets section in the charge case documentation. In the Auracast framework, the role of the charger case is an assistant. Through the display screen on the charger case, you can control the earbuds to select and receive audio sources in the air. For detailed information, please refer to the Auracast Assistance section in the charger case documentation. There are mainly 8 files related to the GUI, with their functions from top to bottom as follows. 1. GUI frame rate testing. 2. GUI data source. 3. GUI initialization. 4. GUI and app task message handling. 5. Files for adapting the GUI engine. 6. UI design, including the battery case demo. 7. Files for adapting drivers. 8. UI resources. GUI initialization mainly includes the initialization of drivers, flash resources, and PS RAM, as well as the loading of the UI design. The macros Target LCD device and Target Touch device are used to select the drivers for the LCD and touch functionalities. LCD width and LCD height are used to define the width and height of the screen. The GUI port DC.C file contains the initialization for the screen display, including the setup for refreshing the buffer and setting the information required by the GUI engine. The GUI port indev.c file handles the initialization of the touchscreen part, including the setup for touchscreen interrupts and the time threshold settings for each touch action. The function of the files under the DB is to save data information transmitted from the app to the GUI. Based on the source of the information, they are roughly divided into 3 categories. The file app panel breader db.c contains information related to the charge case connecting to devices via classic Bluetooth. The file app panel db common.c contains some common interfaces or variables. The app panel device db.c pertains to the information of the battery case itself. And the app panel ledb.c contains information for devices connected via low-energy Bluetooth. The function of the files under message is to save data transmitted from the GUI to the app, based on the destination address of the data transmission. They are also roughly divided into 3 categories. The file app panel breader message C saves data transmitted to devices connected to the charge case via classic Bluetooth. The app panel device message C pertains to the data of the battery case itself. The app panel LA message C saves data for devices connected via low-energy Bluetooth. The last, files app panel message C and app panel message util.c contains some common interfaces or variables. The entry point for the UI design code is within the app panel UI design interface, and the 3 demos currently provided start from here. Under the panel user data path, based on the IC type, there are UI resource addresses needed for compiling the app binary. These resource addresses are generated in a header file when the user data binary is created. This header file contains addresses for various resources, such as fonts and images. For more detailed information, you can refer to the UI design section in the charge case documentation. There are 2 communication links between the charger case and the headset. One is a serial port, which is used while the headset is inside the case. During this time, the automatic pairing feature is supported, and the charge case can also use this link to inform the headset of the open and close status of the case. The other link is a Bluetooth Low Energy link, which maintains the connection between the headset and battery case when the headset is outside the case. Through this link, the headset can notify the charger case of certain information about itself or the smartphone, and can also control some functions of the charger case, including Find My and Lay broadcasting. For detailed information, you can refer to the communication between charging case and headset section in the charger case documentation.